So, welcome everyone to today's live. Today, we are going to be talking about networking and cloud networking. So, how you can find today's project is by finding the Nextdoor community. And if you don't have access to the community yet, that's totally okay. All you have to do is sign up from the link in the bio. And once you're here, just click on all AWS projects on the very left-hand side of your screen. And we're going to find our project today by scrolling down a little bit and clicking on this link that says Project 12. Once you click here, you're going to see that there's a page called Cloud Networking Build a Virtual Private Cloud. And you can start your project right away by clicking on the steps right here. Start your project here. This is a project that's been in the making for quite a while now because I feel like this project has been, I would say, one of the most requested projects out there. Absolutely, it has taken a little while for us to prepare everything. But now that we're all here and we're all ready, let's get started. Cool. So once you click on this link, start your project here, you will get taken straight to a project guide right over here, build a virtual private cloud. And I would say this project will take about 60 minutes to complete for complete beginners. If you are someone that has already done if you're someone that has already done like a networking project before, it's probably going to be like 30 minutes. Cleopatra in the chat says, "Hey Natasha, just an FYI, the link for this project is incorrect on the website. It leads to the CI/CD with Code Pipeline project." Oh my gosh, you're so right, Cleopatra. It has led to the wrong project in the past, but I have updated the link now. It should be correct now. Please give it a check, and please update me in the chat if you are still seeing the CI/CD Code Pipeline project or if it's showing you the virtual private cloud project now. Okay, so let's get started. Again, once you find the project in the Nextdoor community, just click on this link here, start your project here, and you will get taken to this step-by-step guide that we'll be following today. And yeah, Linda says, "Cleopatra, thank you for asking." Yeah, a big shout out to Cleopatra for that one. All right, so when you have your step-by-step project guide open in front of you, and I have it open in front of me on the right-hand side of my screen today, you will open up your Amazon AWS console. So this is my console right over here. I have it open. You don't have to use your IAM administrator account in order to complete this project, but if you do have an IAM admin user, absolutely use that. You can see that I am using my IAM admin user. The reason for this is because using an IAM user is absolutely best practice for your account security. So just let yourself take that extra 2 minutes to switch accounts from your root user to your IAM admin user if that is you today. Otherwise, if you are not familiar with what an IAM admin user is, we have gone through how to create one in our DevOps project about how to create a web app, an ID in the cloud. You can find a link to that in the description as well. All right, so once you're here with your IAM admin user, you can get started with the project. Now, Ashish in the chat says, "Hi, new here." Very cool. Hi, Ashish. All right, so our 30-second summary for today's project. This is probably your very first AWS networking project. If you're a complete newbie to AWS, welcome. I'm so excited that you're here. And in this project, we're going to dive into the very core of AWS networking by creating something called a virtual private cloud. Often you're going to see people call a virtual private cloud a VPC, and we might refer to it as a VPC throughout this project. Just know that it stands for 3 very simple words: virtual, private, and cloud. What a virtual private cloud really means will make a lot of sense once you learn what networking means and eventually why virtual private clouds exist. And we're going to run through that very, very quickly. So if you have no experience at all with networking, if this is the very first time you're even hearing about the words networking, this project is still absolutely for you. And yeah, let's start from the beginning altogether. So, setting up and managing a VPC, a virtual private cloud, is a vital skill for anyone looking to master cloud infrastructure. Even if you don't think you'll be someone that's going to be a network engineer or you want to specialize in networking, just having that base level understanding of virtual private clouds and why they exist, how they work, is crucial. I absolutely vouch for that. So, in today's project, let's get ready to create an Amazon VPC. And once we create that Amazon VPC, we're going to create two other components. One of it is called a public subnet, and the other one is called an internet gateway. So yeah, we'll be creating not just a VPC, but also two very, very important components, a public subnet and an internet gateway. Again, if this is your very first time hearing these terms, we're going to be breaking down these words as well on top of creating them from scratch. Pretty exciting stuff. And the graphical kind of representation of what you're going to be creating here is shown here in this architecture diagram. So you see how step one, we're creating an Amazon VPC. That is this, I guess, wider square that you see here. You can absolutely represent it as this kind of square in an architecture diagram. And the second part, create a public subnet. Now you'll see that the subnet is something that falls within the VPC, and you're going to see that in action in just a second in the project. And the third thing is to create an internet gateway. Now, again, notice this diagram. Notice how you have your VPC, which is kind of like a bigger square, bigger net. And then you have your public subnet that falls within the VPC, so it's inside. You can think of it as a subsection. And then the third thing we're going to create is an internet gateway, which lives outside of the VPC, but, well, we kind of attach it to the VPC. And overall, what is this big yellow square that's covering the entire diagram? It is the AWS cloud or your region, the region that you're going to be using your VPC in. Now, with every project, you can always choose which mode you'd like to do it in. So would you like the low touch mode, which leaves most of the steps up to you? It's great for those looking for a challenge. You don't really want to be told exactly where to click, what to do, but you do just want to have some general guidance around, okay, this is the goal, go and do it. Now, the second version and the alternative is called high touch. This high touch mode gives you step-by-step instructions for every single part. It is great for beginners. Absolutely, that's going to be the mode that we'll be using today as well. So let's go for high touch, and here we go. You will see the step-by-step project guide right here. A big shout out to everyone in the chat right now. It's feeling lots of love. Abdul Rahman, thank you so much. Abdul Rahman says, hi, Natasha. Happy to be here again. Me too, me too. I'm very happy that you're here again. Plaxides says, hi, everyone. Oh, I'm saying hi back. Thank you so much. All right. So let's finally get started with this project. You have your AWS account open in front of you. Make sure that you are mindful that you need to delete all of your resources by the end of the day. And if you ever get stuck, ask the Nextware community. Students like you are already asking questions about this project. I released this project, I would say about 5 hours ago, and I've definitely received questions about it already. I love just how everyone is so active in the community always and asking questions is what we love. You can make a copy of this documentation template today by clicking on this link here. And once you click on this link, it will take you to your documentation template, which looks like this. So once you have this documentation template in front of you, make sure that you are not trying to edit it directly. You will see that you can't edit a template directly. You're going to have to learn how to click on File on the top right-hand corner, and then let's make a copy of this documentation template. Now this is how you can actually create a template or your documentation that you can edit. So you can see that I can actually click inside here and I can actually make my edits. And the very first edit you can make is just replacing your name with, well, your name. So I'm going to replace that with Natasha Ong. And I think we can jump straight into our AWS account and do step one of the project now. Cool. Now, step one of this project, like we mentioned before, is to create a VPC or virtual private cloud. And what that looks like is this blue kind of square here. You are here. This is step number one. So in your management console, in that search bar at the top, over here, let us type VPC. So let's type VPC over here. and click in the very first search result, VPC. Wow, and while that's loading, a big shout out to Michael Winton in the chat. Michael Winton says, so excited. Thank you, Nat. Let's do this. Absolutely. Wow, I love the energy. Thank you so much. Let's do this. And now that you're in your VPC and in your VPC dashboard, you're going to be like, whoa, there's a lot of things going on in here. Completely agree, by the way. There's a lot of things going on in this dashboard. But thankfully, we're not going to be going through this dashboard. It is quite advanced stuff. Today, we're actually just going to click on your VPCs on the right here, on the left, and click on that. And you're going to see, it looks much, much simpler. So this looks great. I can see this is a random thing here that we don't need. So I'm going to quickly delete that over here. We don't need that. So let me delete this before I start my explanation. Now, when you select your VPCs for the first time, this is what you're going to be seeing. One row of an existing item, an existing VPC. And you're going to think, why does a VPC already exist in my account? You've probably never had to create a VPC before, but this exists in your account already? How is that possible? Now, to really understand why this VPC is already in your account, let's first actually talk about what is VPC in the first place. So if we imagine your AWS region as a country, a virtual private cloud or a VPC, it's like managing your own city inside that country. So in my case, my region is Oregon over here, and your region might be something completely different. But let's imagine that that region that you've chosen is a huge country with lots of space. And well, that is very, very true, because I guess in the world of cloud computing, in the virtual world, the space can be like infinitely big. But let's just say that in this huge country that is your region, your virtual private cloud is kind of like your own city, your own space within that region. And in this own space that you own, you can design neighborhoods. These are called subnets, which we'll be creating in step 2. You can create traffic rules, you can create security measures, and you can also control how different resources that live inside your city, like EC2 instances, like S3 buckets, how these are connected and work together. So if you think about your region as a huge country filled with all of the resources that gets deployed into your region, your VPC is kind of like that city that's like, hey, this is Michael's AWS account, and everything that Michael creates is in this little city. And that is what your VPC is containing. So your city is isolated from all the other cities, which are, all the other AWS accounts within the region, which gives you full privacy and full control over your VPC's layout and rules. Now, what is the point of having VPCs? Why do they matter? You might be thinking, okay, why does it matter that I need to have my own city within the region? And to put it simply, if VPCs didn't exist, every single AWS resource ever created will be thrown into one big open space in the AWS cloud. You can think of VPCs as the reason why, when you create a resource, why is it that it's only contained into your account? Why isn't it that a resource that you create is something that everyone in the entire world can see? Why do you have privacy? Why do things like, accounts and these like boundaries around our accounts exist? These things exist because of VPCs. So in other words, having no VPCs would be like if an entire country didn't have concepts of cities, towns, districts. There's no concept of like roads and all the buildings. Imagine a country where all the buildings, all the homes, all the businesses and public areas, they're just randomly scattered across the land. And there's just no concept of a neighborhood or road or boundaries. It's kind of like, just imagine how chaotic that would be actually for a whole country to be run like this. Imagine trying to find your house or office when no roads exist and no concept of like, this suburb or that city exists. There'd also be no privacy. So imagine if in that big city, in that big country, if you were to like create a resource, everyone can see and access that resource. No boundaries are in place after all. So there's no such thing as like this is yours and this is mine. Everything that gets created gets put in the exact same place. Um, so VPCs are kind of the reason why resources can even be made private to you. VPCs are also the reason why you can set up your resources to communicate and integrate with each other. For example, an EC2 instance with an S3 bucket. Even with these boundaries in place, how is it that your resources can actually still talk together? It's because you can use VPCs to set up that line of communication between them. Now, I know that networks and VPCs specifically have always been quite a tricky topic to navigate. So I would highly recommend that if you have any questions, add them to the chat, add them to the comment section, and let's talk about it. Or you can ask your questions in the community as well, and we can continue talking about it. Because I would say networking, while it is quite like a confusing topic or it can be quite hard to understand, it is just so important to get an understanding of it so that a lot of the other AWS services like EC2 instances or CloudFront or a lot of other resources that have to do with like deploying your resources and making it available to the world, a lot of making that work depends on you really understanding why VPCs exist and how you can make the most out of it as well. But if I were to summarize everything that we've just talked about here, I always personally think about VPCs as the reason why when I create my resources, it is only visible and private to me until I really want it to be public. So VPCs are the reason why I can make things private to my account, and they're also the reason why things can also be made public to the entire internet. So that's how I always distill it in my mind. I hope that helps. Awesome. Wendy in the chat says hello. I'm saying hello back, Wendy. Hiya. So, before we keep going, all that chat about your region being like a country and your VPC being a city, let's also make sure that your region is being set to the correct region, the one that's closest to you. So I'm going to be picking Oregon. And yeah, you'll notice that there is already a VPC in your account, right? And like we mentioned before, VPCs are the reason why resources can be made public or private to you. So when you create your AWS account for the very first time, AWS is going to provide you a default VPC, which is this VPC that you see here in your account, to help you quickly get things started. So this VPC lets you launch resources like your EC2 instances. It lets you test AWS services without needing to set up a VPC from scratch. In other words, this default VPC is the reason why you've been able to privately deploy your resources without having to set one up, when you first create your account. This default VPC is a very handy starting point if you ever want to test resources or just want to deploy things quickly. But often, if you're ready to create your own custom application, if you have your own requirements, you'll be creating a custom VPC, which is what we're going to be creating in a minute. Cool. And another thing to mention, we've had questions before around, does that mean VPC is the same thing as the internet? And it's easy to think that. I think it is really easy to think, if VPCs are the reason why things can be made available to people, maybe it's just the same thing as putting something on the internet. Maybe my VPC is the same thing as the internet. But no, they are completely different concepts. A VPC isn't the same thing as the internet. Think of a VPC as your own private city, right, in the cloud. And it's like having just this fenced off piece of land online. In contrast, the internet is like a huge public city where everyone can visit. You can connect your private city, you can connect your VPC to the internet with something called an internet gateway. And that's basically this little guy here in this diagram. And you're going to learn more about an internet gateway soon. But absolutely, VPCs are not the same thing as the internet. You can think of VPCs as kind of like your private area of the online world. But the internet is kind of like this very public space where you can literally go into your browser and type something and anyone can access it. So you think about them as different things. So with that being said, let us create our very first VPC and just watch VPCs work in action. Let us click on Create VPC on the top right-hand corner of our console. And in terms of how we're going to create our resources today, let's just select VPC only. If I were to select VPCs and more, by the way, just out of curiosity, you're going to see some pretty interesting and funky stuff. And this is something that we'll get to touch on later on in this networking series when we're more familiar with the different parts of a VPC. But for now, we're going to do everything from scratch so that we can really learn everything from the foundational level. So once you've clicked VPC only, let us add a name tag. So a name tag is basically what you're going to call your VPC. And we're going to call this Network VPC. And here, you are also creating something called an IPv4 CIDR block. And what you need to specify is what is the IPv4 CIDR itself. Now, the CIDR that we're going to be specifying is 10.0.0.0/16. And we're going to take a pause here. You're going to notice that we're going to take a lot of pauses throughout this project, actually. Instead of I guess, doing a lot of action in the AWS console in this project, a lot of it is going to be us just having a chat and just talking about what these different things mean, because this project is going to introduce a lot of new networking concepts to you, and we just want to make sure we set these foundations right before we try to do some crazy cool things later on in this series too. Maud in the chat says, is creating a VPC free in the console? Very, very good question. I really like this question because the answer is also quite an interesting one. Creating a VPC itself is absolutely free in AWS, but not every single thing in the VPC console is free for you to create. What we're doing in this project today is completely within the free tier, so you can do all of that, no worries. But there are often things within a VPC that you can add. And in this project today, we're going to add something called a subnet. We're going to add an internet gateway. These are free to add, but there are also some other things you could add that cost money. So the biggest example that I have in my mind right now is called a NAT gateway, an NAT gateway. We won't be touching it because, again, it is something that costs money to add. But overall, a VPC is free to create in the console. All right, so as I mentioned before, a lot of this project today is going to be us just having a good yarn and talking about what these different concepts mean. And I think it is going to be a bit tricky trying to understand networking in general if we don't understand what IP means or what IP addresses mean and how to understand things like 10.0.0.0/16. So let's have a quick talk about what this means. Now, what we've inserted over here in this IPv4 CIDR field, what we've entered here is kind of, here is an IP address, and then over here makes it like a CIDR block, the /16. So what is 10.0.0.0? That is an IP address. So an IP address is like a street address, or it's like coordinates for the resources in your city. So remember how your VPC is your own private city? So an IP address is kind of like your street address or your coordinates. It is how your VPC is going to identify where your resources are. Configuring IP addresses in your VPCs, just make sure that each resource can be uniquely identified and located. It lets resources find and talk to each other without any conflicts. Now, in this case, what we're doing here is we are basically setting up a CIDR block. And a CIDR block is basically a range of addresses, a whole block of addresses. So if we were to say 10.0.0.0 is a single address, it's kind of like, hi, I live on number 5 on Main Street. That is like one single address. 5 on the 5th thing on Main Street is one single address, but once you add a whole CIDR block /16, for example, you're basically giving a whole range of addresses. It's like all addresses from this street all the way to that street over there. So that is the difference between having an IP address simply like this versus a whole block of addresses, which you'll create by adding a slash and then a number. Now, what you're going to notice is that the other thing with our IP address here today is that we're saying IPv4. So IPv4 stands for Internet Protocol version 4. And it's most widely used way to write an IP address, and IPv4 addresses are written as 4 sets of numbers separated by dots. So, this example in the guide here gives you another example of an IP address. It's 192.168.0.1, and that's absolutely an IP address, just like the IP address you're seeing here, the 10.0.0.0. And all numbers between the dots in your IP address have to fall between 0 and 255. So 255. So this means IP addresses can start from 0.0.0.0 and literally go all the way to 255.255.255.255. Oh my gosh, I got tongue-tied there. But you can imagine it being a huge range of IP addresses that exist out there, so many different combinations, and that's why there are a total of 4.3 million possible IPv4 addresses out there. In general, 2 devices can't share the exact same IPv4 address in your network, so it's kind of like saying 2 houses can't really share the exact same address in a city. There's got to be something that's somehow different, whether it's the number on the street name, or like your postcode number. There has to be something that's different, and that's the same thing for IP addresses. 2 resources must always have a different IPv4 address within your VPC, within your city. Now, you might also be thinking, oh, this is quite interesting. Why is it just between 0 and 255? How is it that IP addresses, like the numbers in between, stop at 255? It's a bit of a specific number, and there's actually a very technical reason behind this. So what I'm going to say in the next minute is a bit of an extra for experts, but I think it really helps with understanding how IP addresses work. So the reason why the IP address and the numbers between them can go between 0 and 255, it's because machines and humans honestly speak completely different languages. And when we read an IP address, we're seeing a number that's like, 0 to 255. And that's because our number system has numbers from 0 to 9 for every single digit. But what if our number system only has 2 possible numbers, 0 and 1? This is the system, the binary system, which is basically, you can think of it as the languages that our machines speak. So while we have the digits in our number system can go from 0 to 9, for computers, it can only go from 0 to 1. And that's why the way that they register numbers is called bits. And every single IP address out there is actually written in machine language. It's actually written in the language that our machines speak. It's in bits, so it's only in zeros and ones, 0 and 1, 0 and 1, 0 and 1. But it would be way too long if we were to actually try to understand an IP address from reading that number in zeros and ones, zeros and ones. We have to condense it somehow, and that's how we condensed it, by saying 8 bits can represent any number from 0 to 255. So if you were to see the numbers 11111111, that is basically a combination of bits that represents 255, and that is the maximum number of like representations or combinations that you can create with 8 bits, whereas the starting number is 0, which is represented by 8 zeros. So that's why IP addresses can start from 0.0.0.0 and go all the way to like this huge number here. It's because actually IP addresses are written in a series of very, very, very long zeros, combinations of zeros and ones, and we pretty much summarize that series of numbers by using bits and converting some of those zeros and ones into blocks of 8, and from those blocks of 8, converting those 8 bits into numbers, into a number between 0 and 255. I know that was very, very technical, but what you needed to really get away from that is that out of these 4 kind of parts, every single part of an IP address represents 8 bits. So you can see that in total, because there are 4 parts to an IP address, in total this IP address represents 32 bits of data. Now, where this becomes a bit interesting is when we're talking about CIDR blocks. Now, that's why we have this thing here. IPv4 CIDR is 10.0.0.0/16, and CIDR blocks are basically how we can create that subsection of addresses, this whole range of addresses. And if my CIDR block says 10.0.0.0/16, what it's really saying is that /16 means the first 16 bits of your IP address is fixed, and then the number of bits that vary are the last 16 bits. So remember how we said that an IP address consists of 32 bits in total? So if we were to break that down and we were to say, oh, we want to create a range of addresses, where does that range start and where does that range finish? In this case, if we were to say that our CIDR block has /16, we're saying that the range lies between 10.0.0.0 to 10.0.255.255. And what that means is that first 16 bits, or that first half of your IP address, is fixed. So we're going to say every single address in the CIDR block has to start with 10.0, so we can't make any changes in this first half. But you know what? That second half can go crazy. We can have all different kinds of combinations here. So every number in this part can be 0 to 255. Every number in this part can be 0 to 255 as well. So that's why the smallest IP address will be 10.0.0.0, and it can go all the way to 10.0.255.255. So what you really need to take away from this part is just to know that if you see a CIDR block, an IPv4 CIDR, say 10.0.0.0/16, what it's really trying to say is, oh yeah, what that means is your IP address can range from this number to this number. And it's a pretty big range, actually. So it might not look like a huge difference, but saying this means that there are 2 to the power of 16, or 65,000 possible IP addresses within the subnet. So when we create our VPC and we're saying, oh, I want my VPC CIDR block and my IPv4 CIDR to be 10.0.0.0/16, what I'm really saying is my VPC will have a total of 65,536 addresses, possible addresses inside of it. All right, I know that was super, super technical. If you have any other questions about this, or you feel like you like more of an explanation, let us know in the chat, let us know in the comments. We can talk about this all day, seriously, all day. I think this concept in networking is so important to grasp. And if that requires literally another good while of explanations, another good while of showing examples and talking about it, let's do it. We'll absolutely do that. All right, so that was a quick brief on IPv4 CIDR. My one-liner to summarize what we've just talked about is basically what I'm creating here is I just said I want to create my own city, my own VPC in my region. So I want to set up my own city within this big country, and I want my city to have a range of addresses. The range of addresses is defined by my IPv4 CIDR. So in my city, all my resources can have a range of addresses that's within this CIDR block. And that means my range of addresses in my VPC can go from 10.0.0.0 all the way to 10.0.255.255. That is a total of 65,536 different addresses that can go inside my VPC. Cool. So with that all set up, literally all of this we can zoom ahead of, and we can actually just create the VPC straight away. Now, before we click that beautiful orange Create VPC button, let's take a screenshot of the setup that we've done so far. So I'm going to take a screenshot of this. And as you might guess, it is documentation time. So once you take the screenshot like this, screenshot taken, let's head to the next slide over here, our documentation template, and let's add our screenshot into that first slide here. So I'm gonna snag that in there. What do we think about the screenshot? Does it look okay? I personally like it if you can see my entire words inside the screenshot. So I'm gonna double click into my image, click, click. double click, and it enters into this view where I can drag my screenshot within this frame. So let me just drag the screenshot down so that you can, when I click away now, you can actually see my entire word create VPC in the screenshot. Beautiful, that looks great. I am going to scroll back up so we can actually write a few words of reflection for our documentation. My first VPC, oof, very cool. All right, VPCs are, how would you explain VPCs? I'm going to say VPCs are isolated sections of the AWS cloud, that help to keep my AWS resources private and secure. And wow, Urban in the chat is giving me a little okay sign. Linda in the chat is also giving me an okay sign. Thank you so much for the support. I absolutely appreciate that. Now, the next prompt says there was already a default VPC in my account. This is true. Ever since my AWS account was created. This is because AWS has set up. This is because AWS has set up. This is because AWS has set up a default VPC. Has set up a default VPC to allow me to deploy resources like EC2 instances or RDS. Actually, this might be a bit advanced, so no worries if you don't know this term yet, or RDS databases right away without having to create my own VPC from scratch. I feel like the sentence isn't the most beautiful sentence ever made in this world. I'm going to say that out loud and admit that to all of you. There was already a default VPC in my account ever since my AWS account was created. This is because AWS themselves has set up a default VPC that will allow me to deploy resources like EC2 instances, RDS databases right away. Awesome. So I feel like it's not the most beautiful sentence, but it does explain exactly why there's already a default VPC in my account. I didn't create this, AWS created it for me. That's the first point we should be mentioning here. And the second thing is this has been created, so we don't have to create it from scratch from the moment we create our account. We can go straight to deploying resources like EC2 instances or RDS databases because this default VPC already exists. If you're wanting a bit of context behind like how having a default VPC allows this to happen, I think we can read that explanation that's further up on the page, which is this. Can I create anything in my AWS account without a VPC? So another reason why VPCs are so important, it's that you can use some AWS services without setting up a VPC. For example, you can still use S3 or you can use AWS Lambda, but there are going to be some resources like EC2 instances or certain databases that absolutely need a VPC in order to even exist. So these services require that secure, isolated network environment that a VPC provides. And that means like if you first create your AWS account and you don't have a VPC, you won't even be able to create an EC2 instance or an RDS database. And now that a default VPC is in your account, that's the reason why when you first create your AWS account, you can go straight into deploying these resources without having to worry about a VPC in the first place. All right, so that was a little tidbit on VPCs. Let me write that very last prompt and we can move on to the next step. Now, the next prompt says, to set up my VPC, I had to define an IPv4 CIDR, which means a range of IP addresses that my VPC can allocate to my AWS accounts, up to the resources deployed into my VPC. Okay, very nice. So I'm gonna make this text a bit smaller so I can make all of my text fit into my documentation template. Maybe I should make it one bit smaller, like this. Okay, this looks good. Awesome. I would like to give also a big shout out to Plaxides, who has a very cool emoji in the chat right now. And we also have Erwin in the chat says, I think also Cloud9 since it creates an EC2 instance in the background. Very good point. Do you mean like Cloud9 we can still use without, oh, do you mean Cloud9 we will definitely still need a VPC in order to use Cloud9 in the first place? Or were you thinking of something else, Erwin? Very, very cool contribution though. Thank you so much. Okay, so that was the first step all done. And the next step is we're going to create subnets. So now that we have created our VPC, which is this pink border here, all done, tick. Next thing is the public subnet over here, which is this blue border over here that we still need to create. I'm going to head back to my AWS console so you can see it as well. And I'm just going to click create VPC so that we're creating our VPC too. Nice, are the VPCs all created now? Very good. Now we have created this one, and now this public subnet is inside the VPC. We are here. Now notice that because it is inside the VPC, that probably suggests that a public subnet is going to be taking from the IPv4 CIDR block of IP addresses that we've defined just now. So it's going to be falling within this wider block of IPv4 addresses. Maud in the chat says, does the IP address only apply to this VPC? Can I use the same IP on other VPC? Ooh, very cool. I love this question. And yes, you can use the same IP address on another VPC. What? Yeah, the reason for that is because VPCs themselves have their own identity, have their own ID. You can literally see my VPC ID over here. So the moment you have your VPC ID, you can then say, this is whatever address this resource has within that VPC ID. You can think of it just like how you can have the same street name in two different cities, and it's totally okay because people be like, "Oh, you're talking about Queen Street? Oh yeah, you mean Queen Street, the one that's in this city, right? Not the one that's in that city." The moment you have your VPC set up, it's like that wider name that you can absolutely use to already start to subcategorize all of these IP addresses. So yes, you can absolutely have the same IP address applied to another VPC. Great question, Maud. Very, very good question. Okay, very cool. So let's scroll down a little bit more and let's create that subnet. So subnet, as you might notice, are like subdivisions within your VPC. So they're kind of like neighborhoods within your city. You have this big city with a whole range of addresses, IP addresses out there, and subnets are kind of like the suburbs that are here to help you kind of break up your city into smaller groups. So let's find subnets in our sidebar. So let's click on the sidebar over here and let's click on the subnets tab. And once we're here in the subnets tab, we are going to notice that there are already subnets in here. Oh my gosh, and there are 4 subnets in here. How is this possible? I only just created a VPC. I haven't created a single subnet, but I already have subnets in here. How's that possible? So, how are there subnets in here? The default VPC provided by AWS comes with predefined subnets in each availability zone of a region. So if you have 3 subnets in your page, that means your region has 3 availability zones. Let me actually change regions so you can see what that looks like. So if I were to go from Oregon to, let's say, Sydney, a different region, how many subnets will I have now? Aha! I now only have 3 subnets. That's because Sydney only has 3 availability zones. Now, if I were to switch back to Oregon, how many subnets will I see? I'm going to see 4 subnets, and that's because Oregon has 4 availability zones. So you might be wondering, okay, first of all, what are subnets? And second of all, what are availability zones? So again, subnets are like those different neighborhoods inside your city. You use subnets in general to group your resources with similar access rules, similar restrictions, they should go within the same subnet. Now, some subnets are called public subnets and some subnets are called private subnets. You can think of public subnets as all of the resources that can be accessed by the public. So these are like EC2 instances that you want to be hosting web applications that should be accessible to the public. But other subnets are going to be private areas with limited access. So these are going to be the resources that contain a lot of confidential information. You absolutely don't want them to be exposed to the internet at all. So these private subnets, for example, can be storing customer databases. Or it can be storing anything related to like a database that contains like passwords. So these could go into your private subnets, whereas the public subnets, anything that needs to be facing the public, so like an EC2 instance that's hosting a web app, will be sitting in a public subnet. So a VPC can have as many public and private subnets as you need. It's not just like you can only have one private subnet and one public subnet. But just know that subnets in the same VPC don't have overlapping IP addresses. So subnets all need to have their own block or their own subsection of unique addresses. You cannot have a single resource that has two IP addresses in the same VPC. So all IP addresses all subnets need to have exclusive IP addresses inside. So I hope that makes sense. Again, add into the chat if you have any other questions about that. So we've just answered the first question, what are subnets? And let's talk about that second question, which is what are availability zones? So to understand availability zones, let us actually zoom out of that city analogy that we've been talking about. Remember how in this diagram, you see how you have your VPC, which is huge, it has like 50 something thousand addresses inside, but this VPC still sits inside a bigger thing called an AWS cloud or your region. So let's zoom out into the bigger picture. You have this big AWS cloud or this big region. And, whenever you've been doing AWS projects, you'll notice that you've been doing them within a specific region like Oregon, or you can do this in North Virginia, Ohio, whatever region you pick. So how are these regions being powered? You will first learn that each AWS region isn't powered by a single massive data center. It's not like a single massive, like huge office in your region that's like powering the entire region. A region is actually a collection of availability zones. So a region is actually made out of clusters of smaller, I say smaller, but they're still huge, smaller data centers that are dotted around the region. So you can think about it this way. Instead of Oregon having this huge, massive warehouse, this huge, massive data center that's somewhere hidden in Oregon, or this Oregon region in AWS is powered by 4 small clusters of data centers dotted around the region. So whenever I am deploying a resource or whenever I'm needing a server to be hosting my resources, it's the host server is going to be belonging to one of these availability zones, one of these smaller clusters of servers. Mod asks in the chat, in a way, you cannot have 2 Queen Street in a VPC. Yes, it's a very, very good point. You cannot have 2 exact same addresses. You cannot have 2 different resources with the exact same address. So think of it this way. If you're pointing at a specific location on the ground in the city, there's no way that that specific location has 2 houses on it. Like it is just there's like one house, one building. So when you're looking at a specific address, only one resource can have that address in your VPC. You can't be saying, oh, there are 2 houses that live on 46 Queen Street or like 2 Queen Street, because technically only one house owns that address, right? And if you're going to be bringing up apartments and saying like, but can't you say like an apartment building has like 46 houses? Yes, and each of those 46 houses will have their own unique address. It will be like, I live at 1A/2 Queen Street. I live at 1B/2 Queen Street. Again, that is still a completely unique address. And it is the same case for IP addresses. like you can have like um, two addresses that start with the same set of digits, but at least one digit in your IP address has to be different, so that each resource has their own unique IP address. I hope that makes sense. Let me know if that sounds good. Um, okay, very, very cool. So we've just talked about availability zones, and we've talked about how the number of default subnets in your account is equal to the number of availability zones in your region. So why does that exist? That exists because when you create a subnet in your VPC, you are assigning your subnet to one particular availability zone instead of the entire region. This detail is very, very useful in more complex setups. By spreading your resources across many availability zones within the region, you are essentially creating backup options. You can think of availability zones and the fact that there are like multiple of them instead of like one big data center. It is the huge benefit of that is the fact that if one data center goes down, it has issues, other availability zones can step up to keep your application running so you and your users don't see any issues at all. And if you're still a bit curious, how can I find out how many availability zones are in my region? You can use this AWS map to help you. Check out this regions and availability zones map if you ever like to explore, all the regions in the AWS cloud. I'll click into it so you can have this quick preview. But here you go. So if I were to click into it, you can see this map is quite an interactive map that can show you, okay, so say I'm in North America, this map is going to show me that, I have 3 availability zones in Ohio. There are 3 availability zones in Canada Central, interesting, 3 availability zones in Canada West, and you can absolutely move around different regions, different parts of the world, and see how many availability zones are across the world. Quite an interesting little concept, and then I think this map does help you makes things a bit more concrete in your mind as well, like how availability zones work. But enough of that little sidetrack. I think we're going to go back into our AWS account and start creating a subnet for ourselves. So I'm going to click on Create Subnet, and under VPC ID, make sure you're selecting the VPC you've just created, which should be called Network VPC. And then notice that it already says associated VPC CIDRs 10.0.0.0/16. That's exactly the CIDR block that we defined earlier in the project when we created our VPC. So it's nice to see that it's like kind of repeated back to us now. And in your subnet settings, let's give your subnet a name, and let's also give it an availability zone. So my subnet name is going to be public 1. And the availability zone, you can just pick the very first availability zone in your list, like this. And then you'll see the VPC CIDR block. Again, it's already been filled out for you. But what we're going to do now is write down the CIDR block for this subnet. So the VPC CIDR block has already been defined, but right now we're creating a new neighborhood and we're being asked, oh, what range of addresses should be in your neighborhood? How big should your neighborhood be? And we're going to write down here 10.0.1.0/24. I think we're actually going to do 10.0.0.0/24 like this. Yeah, I think this looks better. So again, the moment you type this down, notice how over here it already says 256 IPs. What does that mean? It means this CIDR block, or this range of IP addresses that we've defined here, represent 256 different IP addresses inside it. So that's really cool. If I were to again copy this in, so 10.0.0.0/16, look at that. Look at the number now. It becomes 65,536 IPs. And absolutely, we don't need this subnet to be the entire size of our VPC, and that's why we just created 24 here to create a range of just 256 addresses instead. So if you're thinking, oh, how is it that when we write 24 it becomes 256 addresses? Writing /24 in your CIDR block now means not just the first 16 bits that are fixed, it's the first 24 bits that are absolutely fixed in your address. So 10.0.0.0 is always going to be the start of your address, but then the last 8 bits here can range from 0 to 255. So you might, again, think about that. My addresses can go from 10.0.0.0, that's the smallest address that can go into my CIDR, that can go into my subnet, and the largest address that can go in my subnet will be 10.0.0.255, right? That's the biggest address. So how many addresses could be in between? 10.0.0.1, 10.0.0.2, 10.0.0.3, 4, 5, 6, 7, all the way until you get to 255. That's the range of IP addresses that can go into your subnet. And that's the reason why when you write 10.0.0.0/24, it's going to give you 256 IPs, because that's the same as, going from 0 all the way to 255. There's going to be 256 addresses in between all of that. So super satisfying when you see the maths or like the logic all work out and kind of validate each other. And that is absolutely a moment here, kind of like writing /24 and then seeing that AWS suggests that this means you'll get 256 IPs, a range of IP addresses within your subnet. So let's recap this right away. Basically what we've created is we've created this VPC that has a whole range of addresses inside of it. In fact, there's like 56,000 of them. And then what we've just created is a subnet, which is like a subsection of that 56,000 that represents 256 IP addresses over here. Joe Chang in the chat gives me a cat. Thank you so much for the cat. I love that cat. It looks so cute. All right, so once we've set that up, I think what we can do next is click Create Subnet. So I'm going to click on Create Subnet over here. Oh, and off it goes. It starts creating for me. Very, very cool. So this graphic is just here to kind of explain what I've talked about over there, what I've talked about just now. Your VPC has a huge CIDR block that represents millions. This is like millions of IP addresses if your CIDR block starts with a 0 and it doesn't have the slash. So this is a bit of a typo, but this CIDR block actually represents 56,000 addresses, not 4.3 million. And then within those 56,000 addresses, your public subnet is kind of like that little slice. It's like a slice of a cake. It's like a little region within your city. And this little subnet or the subsection has 256 IP addresses, out of the 56,000 that your VPC owns. Now, if you were ever to launch an EC2 instance, if you were to ever create a, if you ever were to create a resource, within your subnet, it's going to have a address, a very, very specific address, and note how it doesn't have a slash at the end of it. See, there's no slash at the end of it because your EC2 instance is just going to have a very specific address. It's just going to have like 2 Queen Street as its address, right? It's not going to have a range of addresses. If you were to ever write a range, that's when you write the slash. But if you're not writing a range, you're just writing an IP address, you just write the combination. The combination of numbers here. Cool. So I hope that is clear. Again, if you're like, I like more of an explanation, add it to the chat, add it to the comments, let's talk about it. Cool. So once we've set that up, what we're going to do next is we're going to select that checkbox next to public 1 in our AWS console. So select public 1. And in the Actions menu, what we're going to do now is we're going to select something called Edit Subnet Settings. And when we're editing our subnet settings, what we want to do is we want to enable auto-assign for public IPv4 addresses. So click on this here, Enable Auto-Assign Public IPv4 Address, and scroll down, and then we're going to click Save. Cool. So what did we just do just now? What did we just enable? So by enabling auto-assign IPv4 address, when you select that check, all you're doing is you're basically saying any EC2 instance that gets launched in my subnet will automatically be accessible from the internet, from from the internet with a public IP address. So to make that very clear, let me just actually open my subnet settings so we can see that tick again. Literally in this panel, auto assign IP settings, it says here, enable AWS to automatically assign a public IPv4 or IPv6 address to a new primary network interface for an instance in this subnet. Okay, so this line is basically saying any EC2 instance that gets launched in your subnet, that 256 addresses that you've specified just now, that subnet, yeah, any EC2 instance that gets launched in there, they're going to automatically get assigned a public IPv4 address. And when I say public IPv4 address, what that really means is this address can be accessible from the internet. It is made public to the world. Ticking this, enable auto assign, just means that in the past, you will have to manually go into your EC2 instance's settings page and be like, I will give you a public IPv4 address to make you public, to make this instance public. And by enabling auto assign, we're basically saying, okay, all of the EC2 instances in my subnet now are gonna get that public address automatically. I don't need to manually go into every single EC2 instance's settings page and set this up by myself. So it is a bit of a time saver. It's kind of like an automation that we've just set up. Cool. So you've just done that. So give yourself a pat on the back. You've just set up auto assigning public IPv4 addresses. So that's a huge achievement. Nice work. Erwin in the chat says, can I move my house to a different address? Can I give it a different IP address? Ooh, this is a very good question. I think that this can apply to some resources, but not all. Off by heart, I believe that not all resources can be moved to a new address. A lot of the time it is quite like a sticky situation if you were to ever want to change your IP address, but it is possible for some resources. It is a bit of a case-by-case basis. If you have a specific resource in mind or a specific use case in mind, add that to the chat. It'll be fun to chat about it. Okay, very, very cool. Let us now talk about the next thing. So if we were to take a screenshot of our subnets panel, we now need to write a reflection of our experience in the documentation template. So let us take a screenshot now and let us write our reflection. So I'm going to take a cute little screenshot, just like this. Ooh, of my entire subnet. Like that. And I'm going to add that to my documentation template. And let me just paste that in here. Boom. Wow. What I've added is a huge screenshot. You know, it doesn't fit into it very, very beautifully. So what I'll do is over here, I'm going to get to the edge of my screenshot and I'm going to try drag that edge up. Okay. And then from the bottom of my screenshot, drag that edge down. Beautiful. Now, this looks a lot, this screenshot now has a much better size. And I'm going to select this arrow and select this white text and move both of those up. Boom, just like that, to give my screenshot a bit of space if I want it. I think I'm going to move it back down a little bit. I think this is just an aesthetic preference now. And let us get straight into filling out the prompts. Subnets are, ooh, good prompt. Subnets are subsections of my VPC, just like how neighborhoods are subsections of a city. There are already subnets existing in my account, one for every availability zone in the region that I've set up my VPC in. Since my region is Oregon, which is US, I think it's US West 2, or is it US East 2? I'm going to quickly double check that. My region is US West 2. Since my region is Oregon, US West 2, which has 4 availability zones. I had 4 default subnets already. That's the truth. And I'm going to change that had to have 4. And I think that prompt is all done. I named my subnet public 1. That's true. But that doesn't automatically make my subnet a public subnet. This is true. This is very true. For a subnet to be considered public, it has to be connected to an internet gateway. Now, did we skip the part where we talk about how it needs an internet gateway? I think we might have. Yes, there we go. I think this actually needs to be maybe further up. Okay. Oh, I think we got it. So in this explanation, what is the difference between a public and a private subnet? We pretty much talk about this other problem that we just completed. A public subnet is connected to the internet through an internet gateway, which means resources inside a public subnet can communicate with external networks. So that's why even if our subnet has already been given a name, a fancy name called public 1, it's not a public subnet yet. It needs to have a route to an internet gateway. It has to have a route to an internet gateway for it to be considered a public subnet. And in contrast, if you were wondering, there's also something called a private subnet, and that's different from a public one. A private subnet does not have direct internet access at all. It's used for internal resources. It's used for that confidential stuff. We talked about having databases of customer information that absolutely belongs to a private subnet. And yeah, this separation between public and private subnets, it just really helps to design secure environments, like a very secure architecture for the applications that you get to create in the cloud. Okay, so now that we've got that out of the way, we are now ready for our very final step in today's project, which is to create the internet gateway. So VPC done, subnet done. Time for the last step to connect our VPC to the internet with an internet gateway. Here's what the architecture diagram looks like now. So again, we have our VPC, which is like this big city inside our country, which is our region. So if we start with our region, like Oregon, think of our region as a big country of many, many, many different cities. And your VPC is one of those many cities. Your VPC has a range of addresses to it, 10.0.0.0/16. That's the whole block of IP addresses that fall inside your VPC. And within that big city, you have a public subnet. You have a little neighborhood that takes up 256 of those IP addresses. And that range is defined by this CIDR block called 10.0.0.0/24. Now the next thing we're going to set up is something called the internet gateway. And this internet gateway is over here. Like we mentioned before, a subnet, a public subnet is not considered public until it is connected to a route to an internet gateway. So what that means is even though we've created a subnet here, it's actually not considered a public subnet yet. It needs to have a route to an internet gateway. So that's why what we're going to do now is create that internet gateway that will later set up a connection with the public subnet. That would later set up a connection to the subnet for that subnet to be considered public. I hope that makes sense. Right now, our subnet is not public. Once we create the internet gateway and we create a route from our subnet to the internet gateway, then this subnet is considered public. Cool. I hope that makes a lot of sense. In the meantime, Fahad in the chat says, Natasha is the best. Thank you so much, Fahad. That makes my day. Wow. I love it. Thank you so much. All right. And you might be thinking, ooh, this is a pretty interesting, pretty important thing. You're telling me that my subnet needs to have a route to this thing for it to be connected to the internet? It must be quite a powerful tool. And yes, it is. As you might expect, an internet gateway is literally a gateway for your VPC to be connected to the internet, a gateway to the internet. So it is also considered like a main entrance or a gate to the city. It also allows not just connection from your VPC to the internet, it's also about people that want to visit your resources from the internet can actually come through. So you can think of it almost like a kind of like how a lot of cities have like docks or piers where ships can exit and leave the city, or it can enter the city. It's also like an airport where planes can depart from the city and fly into the city. That's kind of like an internet gateway. So any kind of data that you want to send out from your VPC into the internet, it kind of has to go through the internet gateway, has to kind of depart from the internet gateway. And same thing for incoming traffic and incoming data. If we have someone that wants to visit your web app, from the internet, it's going to have to arrive through your internet gateway, that pack of data, for it to be able to access your web app. So that's why internet gateways are just so important. Without this gateway from existing, if this didn't exist, your city will be cut off from external access. It's just completely excluded from the internet. In other words, by attaching an internet gateway, your instances can access the internet and also be accessible from through the internet by external users. Now, when we select internet gateways in our AWS Management Console, aha, an existing internet gateway. Interesting. So we created, when we wanted to create a VPC, there was a default VPC in there already. When we wanted to create a subnet, there were already 4 existing default subnets in there. And now when I want to create an internet gateway, I'm seeing that there's already a default gateway in there. What? What is this about? So if you see this existing gateway in your AWS account, you might have guessed that it's associated, with that default VPC that your AWS account has already created for you as well. If you thought that, bingo! This default internet gateway lets you launch instances and have internet connectivity immediately. It's a great starting point for beginners to explore, to use AWS services without needing to configure their own internet gateway from scratch. So the purpose of having this default internet gateway in your account without you even knowing this whole time, it's the same reason as the reason why there's been a VPC in your account this whole time without really telling you or without really you knowing. It is just so that if you ever wanted to create and deploy an EC2 instance that has access to the public internet, that you are able to do that, by default, without really needing to create an internet gateway from scratch yourself. So let us get started by clicking on Create Internet Gateway, and Kiaozao in the chat says, do I need public IP for each instance in public subnet? Ooh, good question. And yes. So every instance, actually, sorry, to clarify, the instances in your public subnet don't necessarily need to have a public IPv4 address, but they need to have that public IPv4 address if you want to make that instance public to the internet. So to make that very, very clear with you, if you have a public subnet out there, that doesn't mean all the resources inside your public subnet needs to be made public as well. It just means that all the resources in that public subnet have the option to be made public to the world. So it just means that you have the option to actually be connected to the internet and have that access to the internet, but you don't necessarily actually have it. all the time. So that's why having that auto assign, that automation just now that we set up in the last step is a great idea, because it just means that now if you were to tick that box, every single resource in your VPC is automatically going to have that public IP address. But if you were to keep that unticked, by default, they're not going to have a public IP address until you assign it, until you create it for them. So I hope that makes sense, and ask me any other questions you have about that. Okay, now that we are going to create our own internet gateway, you're going to configure it simply by giving it a name. And in this case, we're going to call it Network IG. IG stands for Internet Gateway, by the way. And once that's done, all done. Just select Create Internet Gateway. How simple is that? How simple was that? I feel like before the world of AWS and cloud computing, it probably wasn't this easy to create like a virtual private cloud, or to create subnets or to create internet gateways, but we just did that within a minute. So shout out to AWS for making it so simple for us. So we have just created our internet gateway, and select your newly created internet gateway and choose Actions. Okay, so we're going to choose Actions here. And then we're going to click Attach to VPC. Ooh, interesting. So from this search bar, let's find your Network VPC and let's click on it. Nice, done. Once you've clicked on that, just select Attach Internet Gateway, that nice orange button here, and off it goes. So it's just gone to attach your internet gateway to your VPC. And what does attaching an internet gateway to a VPC actually mean? So attaching an internet gateway means the resources in your VPC can now access the internet. You can think of it like this. I'm going to scroll back up to our diagram. So what we created just now was a VPC, right? That was the very first step. And then just now we created an internet gateway. We created this purple thing. But before we done the attaching, this line, this connecting line did not exist, okay? This line did not exist. We had to select Actions, Attach to VPC, in order to establish this line of connection between them. So I hope that helps to clarify why that attaching move needed to happen. We needed to attach our internet gateway that we've created so that it's actually connected to the VPC we've set up as well. Now that they're connected, hooray! Now the resources in your VPC can now access the internet, and the EC2 instances with a public IP address also become accessible to people from the internet. Now people outside in the external, in the public and the internet can also access all of the EC2 instances with that public IP address. Even though you've created this internet gateway and you've attached it to your VPC though, there is still a step left to go. You do still have to tell instances in your public subnet how to get to the internet. It's kind of like saying you've built the roads, you've built that line of connection between your VPC and your internet gateway. But what if the resources, okay, let me scroll back up so you can see this. So let's say that there's a line now between your VPC and your internet gateway. But what if your resources, like this Amazon EC2 instance, doesn't know how to walk that line, doesn't know how to find that line, doesn't know how to get through it, doesn't know how to find, get to the public internet gateway? If your EC2 instances are lost, if your resources don't know how to get there, what was the entire point of attaching your internet gateway to a VPC? You will absolutely need to almost like write instructions to tell the resources in your subnet or in your VPC how to get to the internet gateway. It's almost like writing a map or writing a list of instructions. And that list of instructions or that map is called a route table, okay? And we're going to be setting up a route table in the next project. But in the meantime, that has been a wrap for your very first networking project. So well done. What we'll be doing now is we're going to take a screenshot of this over here, and then we're actually done for today, because that was a very, very packed session, everyone. I know that it was not easy trying to digest what is a VPC, what is an IP address, what are CIDR blocks, what are subnets, what are internet gateways, how do they all make sense, how do they all connect. So I know that even though actions wise, like on this console, maybe we haven't done lots of significant things yet. We're probably going to be needing 1 or 2 more projects after this in order for you to see something very, very visual pop up on your screen. But we decided actually we're going to stop this project over here so that you have the time and space to really absorb all of your learnings from this first project and also tell yourself you've done a damn good job for getting this far, by the way. It is a very, very hard topic, networks, VPCs. So take the time to understand it, take the time to really understand the different terminologies, and do these little steps again and again. Maybe even draw the architecture diagrams yourself as well, because I think drawing the architecture diagrams really help you with understanding the connections between all of the components of the VPC that you're creating. But before I take a screenshot and finish up the documentation, I noticed we also still have another message in the chat. Kyozao says, thank you. If we disable auto-assign IP in VPC, can we assign public IP manually to instance? Absolutely, you can. You can absolutely do that. Okay, so let me take a screenshot of our internet gateways panel so that it's showing my network internet gateway in here. Okay, let's take that cute little screenshot. Boom, done. And let us scroll down over here and attach that screenshot in here. Can I see my screenshot? Ah, it's right up here. So let's attach my screenshot. Again, let me just use the edges of my frame to give me a bit more space. Okay. You know, this looks pretty good. I'm very happy with the look of this. And let us complete the prompts over here. All right. Internet gateways are the key VPC component that allows internet access for the resources in my VPC or subnet. An internet gateway Unique in the chat says, do I need to know networking before I start learning AWS? No, I don't think so. I absolutely think that you can learn both as you go. I think that networking is one of those foundational concepts you'd want to be learning. You know, if you're going to be learning AWS and you want to be a cloud engineer, or you want to be confident about what you know about AWS, I think knowing networking concepts should be a part of that list of like must-learn things. Otherwise, I would say you don't need to have this knowledge before you start learning AWS. There's a reason why it's been able to be project number 12 in our project series instead of project number 1 in our project series. You can absolutely be creating things, understanding things in AWS without knowing networking first up. Just make sure that you eventually come to it because it is quite an essential piece of knowledge. Although quite technical though. So I feel like if networking is the very first thing you learn in AWS, you might find that it is a bit tricky to wrap your head around. There are quite a few concepts, technical concepts you need to learn along the way. Kiao Zhao says, do you mean is that elastic IP address? No, I think elastic IP addresses is a slightly different concept to a public IP address. We can talk more about this in the community. I think this one's a pretty good discussion to have as well. Ooh, Arun says, thanks for this wonderful session. It clarified a few concepts for me. Arun, is that true? That makes me so happy to hear. Thank you so much for leaving that comment. It really makes a big difference. It really does. Hands down, it does. So Arun, thank you so much for being here and thank you so much for leaving that positive message. So I'm going to finish up my documentation by mentioning an internet gateway is also how users in the public can access my resources in a public subnet. Linda in the chat says, thank you, Natasha. Big heart. Thank you so much, Linda. A big heart to you back. That's so sweet. That is so, so sweet. Attaching an internet gateway to a VPC means, oh, what is the impact of attaching an internet gateway to a VPC? Oops, I feel like I just mentioned that in the previous one, but actually there's a full answer right here. You can absolutely just copy that over here, paste that over here as well, but just make sure you understand what this actually means. Attaching an internet gateway means resources in your VPC can now access the internet, okay, which is basically what we mentioned in this paragraph above. The EC2 instances with public IP addresses can also become accessible to users. So your applications hosted on those servers become public too. So this sentence is basically saying this sentence as well. It is basically how EC2 instances with the public IPv4 address we talked about can actually be made public, can actually be accessible to people that are just wanting to visit your server by maybe like typing something into their browser. They can actually get to the resources in your server now. Joe Chang says, always love your positive vibes in the lives you do, Nat. Catch you later. Catch you later, Joe. Thank you so much for being here. And I'm always appreciative of your positive vibes too. Human says, how to be a cloud engineer? Huge question, Human. I wish this is the kind of question that I can answer in just like a few minutes. It is a huge question. How to be a cloud engineer comes down to many, many different factors. But if I were to try to boil it down very, very quickly, first of all, I hope you're a part of our community of people who are learning about cloud computing, who are learning about AWS. Many people are in a similar similar place to you in that journey, where you're just at the very start. You don't really know how to get there. You just know that cloud engineering provides a lot of opportunities and you want to give things a try. Absolutely, if that is you, come join us in the community. The link to that is in the description, Human. But how to be a cloud engineer, I think, really comes down to a few factors, right? First of all, you will understand what are the technical requirements of being a cloud engineer once you read through a few job descriptions about cloud engineering. That will cover your basis around, oh, what are the technical requirements of being a cloud engineer? But there are other parts to being a cloud engineer as well. There's also practical experience that you can absolutely build. So that is like doing projects like these, creating a portfolio of these projects, solving problems with cloud computing service providers like AWS, for example. I think being a cloud engineer, if you're talking about how do I actually secure the job, there's also a huge component around networking. And I don't mean networking like virtual private clouds networking. I mean being able to put yourself out there and meeting people and talking with people and understanding what they do for their in their cloud engineering career, and building that network of people that will also vouch for you in your journey and potentially even introduce you to your next job opportunity. And there's absolutely also the ability to showcase yourself in like interviews as well, by the way, if you're applying for a job. I think being a cloud engineer also comes down to the ability to learn and to adapt and to pick things up as you go. I feel like cloud engineers is such a broad topic, it's such a broad job title that you'll absolutely be learning lots of things on the job as well. We talk about this topic all the time, by the way, in the community. So again, if you're not a part of that community yet, I'd absolutely recommend joining, Human. And I'd absolutely recommend asking this question in the community as well if you haven't found the answer that you've been looking for. Awesome. So with that being said, I have just realized that I still have one more documentation prompt to complete. So thank you so much for waiting if you've just been waiting for me to complete this prompt. This last prompt says, while I've set up an internet gateway and attached it to a VPC, which you have done, by the way, you have set up an internet gateway, you have attached to a VPC, I still have to set up route tables. I still do. Route tables will help EC2 instances, resources in my VPC to find their way to the internet gateway attached to my VPC. Otherwise, even if that connection has been established between my VPC and the internet gateway, my EC2 instances would still be I want to say lost, but I don't know if lost is the appropriate word for this situation. But my EC2 instances would still struggle to access the internet. It's just so funny thinking about this, right? Like you've literally set up the connection already, but your EC2 instances are still lost. They're just like, where? I don't see internet. And you have to use a route table to actually help your EC2 instances basically find the internet gateway. Okay, so that was the last big piece of our documentation done. That felt so satisfying, by the way. If you're still here, thank you so much. And I hope you are also very proud of your documentation. I know I would be if I was the one that wrote the amazing piece of work that you've also done in your documentation template. Okay, so the last bit is to wrap up your documentation. So what this means is going into that last page called My Key Learnings and completing these prompts over here that summarizes some key things that I would have loved for you to have learned from this project. And also one last prompt that says, one thing I didn't expect was ... a very personal reflection that is so valuable too. And then you can write a summary of today's project in the slide at the top that's titled Introducing Amazon VPC. And this is kind of like that wrap-up slide that kind of just says, what is a virtual private cloud? Why do people use it? How am I using it in today's project? And how long did this project take me as well? It's a very good intro slide to have in a documentation. And next, you can absolutely make sure that you're replacing this title page with a screenshot that you have found to be quite interesting or valuable in today's project. And again, don't forget that these things can absolutely be adjusted as well if you ever feel like your screenshot is bigger or smaller. And yeah, don't forget to add a photo of yourself over here. I think I will be doing that too, so let us upload a photo of ourselves. I'm gonna click into, if you missed that action, I'm going to the sidebar and I'm gonna click on uploads and I'm gonna click upload files and I'm gonna choose a file of myself. We recently actually in the team took some team photos, so I'm gonna see if I can actually find that. If I can, that'll be a win. Can I find that? Can I find that? I think so. I think my photos are in here too. Where did it go? Okay, there we go. There's the photo of me. So I'm gonna let that upload. Very nice. Urban in the chat says, insert John Travolta lost meme. Yes, literally that meme. That's the best meme we could use in this situation. If your EC2 instances are still lost, still looking for that internet gateway. So I can't wait for the next project, by the way, where we're going to be creating a route table for it. So now that you've uploaded your image, by the way, all you had to do was, I just had to click on this image and then this image will pop up in my editing screen. And then I just have to click on this image and drag it into, do you see that little space here? That circle, that's a frame for your photo. Drag that into your frame. Boom! Here you go. Here's a space. And you can absolutely double click again onto this photo. Double click like this. And then drag it out like this. Drag out your photo so that you can reposition your face to fill up most of that circle. And you would want to do this because honestly, when someone is reading your documentation, their computer or like their screen is probably not going to be zoomed in. It's probably going to be zoomed out like this. So you're gonna want your face to be super big in that circle so that they can even see it at all. And with that being said, your next hack is, do you see how it says your name over here? Replace and save yourself the time of, adding in your name every single time by just going Command F, which creates a search panel, right? And then in that search panel, you're going to say, find me your name, and replace all instances of that phrase, your name, with my name. Once you click replace all, it's like magic. Now every single piece has your name on it instead of that placeholder text. Very good. And you can do the same thing with your LinkedIn link. So all of them looks like this right now as the placeholder, but you just have to find that and then replace that with your actual LinkedIn URL. So I'm going to call that Natasha Ong for me. And then I'm going to click again, replace all. Beautiful. Now my LinkedIn link is perfect. So the last bit is to fix up this profile circle. So I'm going to drag my photo straight in here. And again, I'm going to increase that size so everyone can see my face in that circle like this. And then once you're done like this, you can click copy, so Command C in your keyboard, and then flick across all of the different pages and press Command V so that you can reposition it. Now you're going to notice that first one that I pasted is a bit out of place. I still have to reposition like this, okay? But once you've repositioned it, this is another hack. Just click on it again. Press Command C on your keyboard one more time. And then you can paste that across your page and reposition that very, very quickly. Very cool. Do you see how now that I am copying it one more time and pasting it one more time, my next screenshot is just paste into it immediately without me having to reposition it again? That's kind of satisfying to me that I don't need to reposition it one more time. And yeah, for that last piece, last photo here, everyone should be in a job they love, and replace this photo with a photo of yourself. So I'm going to do that here. I'm going to click on that photo of myself and replace that here. Done. You can absolutely, again, double click on your photo and you can reposition it. You can slide to the left, slide to the right, or if you want it to, kind of look further up like this, you can just drag your photo up as usual. And then from that top of the image, you want to drag that edge down, yeah, to still review more of you, in that photo. So I hope that helps. And I hope that helps you save a bit of time as well as you tidy up your documentation. Now we're going to wrap up very, very soon. But before we wrap up, some great comments in the chat. Thank you so much. Abdul Rahman says, your steps are simple and great, Nat. Oh, Abdul Rahman, that's so sweet. Thank you so much. I get so shy and so flustered when I see such amazing comments like this. It's so, so sweet of you all. Thank you so much. Us as a team, we're always just fangirling. I say fangirling, but we're always just such big fans of all of you. And we're just so appreciative of all of the kind comments that you leave about our work, about these projects, about the experience of being in this community. It's seriously just such an honor. I can't get enough of it. I absolutely can't get enough. Okay, so now that you're done with your project and you've written up your documentation, give yourself a pat on the back. You've done some great work. And let's get added to Nextwork's Secret Hall of Fame. So share your PDF in the Nextwork community. Just click on this link here, and you're going to see lots of different examples of people who have posted their documentation before. So you're going to get taken to this page called I Have a Question, or you're going to get taken to the All AWS Projects tab. And then you can absolutely, over here, someone in the comments here say, the link in this post doesn't go to the right project. Yeah, Andrew is very much right here. But we have corrected that link now, thankfully. But you can absolutely, once you have found the right project, comment your achievements, attach your documentation as a PDF, and then you're done. It's so funny. I scroll here and I see that something else has the wrong picture. You guys are the best community ever. You should really know that. It's so sweet of you to have you correct us, tell us what we're doing that should be different, because that's how we keep getting better. It's just so funny that the 2 times I review comments in a post, they happen to be the 2 times that someone says, there's something wrong here. Can you please fix this? I will be fixing this right after this live, team. Um, and here we go. Like, when you scroll down through this thread for every single project, you're going to see people who talk about the project, who post their documentation, who post about their experience. I always think the comments thread for every single project is just such a great place to be. And when you're done with your project, you can absolutely post your documentation here as well. We would love to see it. Absolutely love to see it. Okay. And when you're done with posting it in the community, let us post that in LinkedIn as well. Are you ready for that? I hope you are. All you have to do is click on the link over there that's been provided for you, and boom, it's going to open up a pre-filled post with the copy already ready for you. As you can see here, all you'll have to do is click on the little X at the bottom of the panel, and then click on the plus sign that says more. Click on add a document, and then click on choose file over here. Boom, you can choose your PDF. Shout out to Abdul Rahman, who recently created parts 1 to 5 of our Amazon Lex chatbot project and wrote an awesome documentation piece on it. I'm going to attach his PDF as the example. And then once you attach the PDF, add a document title. So I'm going to say the document title for this is Building My Own Virtual Private Cloud. In brackets, that's VPC. Cool. And when you're done with that, you can click done over here, and your LinkedIn post and your documentation, it's all going to look very, very beautiful. And then you're going to click post and you're all done. You've just made your documentation live to the public in a space where everyone can see your amazing progress. It's definitely something to celebrate, definitely something to show off. Don't be shy. And yeah, before you click post, actually, let's make sure that when you get to the massive thanks to Nextwork line, that you double click on Nextwork, and then you select us in the list of options in the dropdown. And what that does is it actually tags everyone in the Nextwork team so that we can come out, congratulate you, like your post, comment, give it lots of love. So it's absolutely something that we love to see when people do it. So again, what that means is you have to highlight or double click on the word Nextwork, and then click on Nextwork from the drop down list of options, and that tags us automatically. Cool. So once you're done with sharing, delete your resources. All right. So you'll notice that we haven't deleted anything yet. We have done a bunch of cool stuff already in our AWS Management Console, but now it's time to delete everything. So let's go into your VPCs, and let's click on Nextwork VPC, and under the Actions drop-down, select Delete VPC, and then type delete. It should be easy as from here. Once you delete your VPC, you're going to see that even under subnets, if you try to refresh the page, oh, subnet's already gone. If you go to Internet Gateways, refresh. Oh, Internet Gateway's already gone. Yeah, very, very, very handy that when you delete your VPC, a lot of the other associated components like a subnet or an Internet Gateway gets deleted with it. Very cool. Now that we're done, oh my gosh, was that your very first networking project all done? Oh my gosh! A big, big, big congratulations to you. I am the biggest fan of you. We are all the biggest fans of you in the Nextwork team. And we want to say a huge congratulations. So as a recap today, you have set up this entire, oh my gosh, I'm lost for words. I'm just lost for words. But you have set up this entire thing of a VPC, a public subnet within your VPC, and an internet gateway over here. Amazing stuff. And I'm going to pause for a second for the chat. Abdul Rahman says, thank you, Natasha, for featuring me when I uploaded your documentation. Abdul Rahman, it's my pleasure too. Michael says, hey everyone, I had a few moments to drop in on the live. I wish I could have caught the entire live. Aw, thank you so much, Michael, for being here. It sounds like you've had a busy day. Please know that all of our lives are recorded as well, so you can absolutely watch the playback from the very beginning and you're not missing a single second. Thank you so much for being here. It truly means the world that you're spending your time with us, like together in this live. Um, and yeah, again, thanks so much for being here on top of your very busy day. So, Unique says, why do we have to delete? Good question, Unique. And the big answer to this is it is very good to have the practice of deleting all of your resources so you don't get charged for anything. We know that VPCs are free to create, but a lot of the times resources aren't free to stay in your account. They might be free for the first day or two, for the first month or two, even for the first year or two, but at one point if you leave enough resources in your account, something's going to start charging you. Okay, getting charged in AWS unfortunately isn't a very rare experience. If you are leaving resources in your account, it it isn't a big surprise if you eventually get charged at some point. And so we want to avoid that as much as possible by deleting our resources as we go. It's a very, very good best practice to have. So I hope that answers your question, Unique. But if you have any other questions about that, let me know. Let us know in the chat. Regardless, today for this project, you've learned how to, number one, create a VPC. That's that pink border over here. Number two, create your subnets. That's that blue border over here. Again, if your AWS cloud, that big yellow border around here, if your AWS cloud, your region is like a big country, a VPC is like your city. It is like your ownership or your part of this entire country. And it contains all of the resources that you deploy that require a VPC. Now, the next thing you did was that public subnet, the subnet over here. My quiz question for you is it actually public yet? The answer is no. Well, actually, yes, because it has been, because your VPC is attached to an internet gateway. But don't forget, your public subnet needs to have a route to the internet gateway. It needs to have that route table. So technically, all of the EC2 instances in your public subnet don't actually know how to get access to the internet yet, even though you have, in step number 3, created an internet gateway and attached it to your VPC. So again, you can think of your VPC as a way to organize your resources, keep it private, keep it secure, keep it organized. Your public subnet is kind of like a folder or a neighborhood within your city. And then your internet gateway is here to help provide internet access to the resources in your public subnet. It's also here so that anyone that's visiting your VPC from the internet can actually get access to your VPC and eventually access the resources in your subnet if they wish to, see a web application, for example, that's in there. Awesome. The bonus is you've absolutely learned IP addresses. You've actually learned about CIDR blocks as a part of this project. We don't really talk about it in the summary, but oh my goodness, it was definitely a huge chunk of it. Learning how IP addresses work, learning how to understand a CIDR block. You are a champion for sticking through all of that. You should be very, very proud of yourself. What you've learned was very technical. It was very difficult. So if you don't understand it from the get-go as well, just know you're not alone. Absolutely, it is not something easy to learn about. So it's so wild that all these learnings are packed in one single project. Great work, and I can't wait to see you in the next one. Fahim in the chat, by the way, says, if I delete, how can I have proof of my project? I love that question so much, Fahim, and it's absolutely the reason why documentation exists. So why is it that throughout this entire project, we've been writing documentation, we've been taking screenshots, we've been pasting that screenshot in here, we've been writing all of our learnings? It's so that we can have proof of our project. Even after we delete all of these resources, absolutely, these screenshots can't lie. These screenshots absolutely is showing all of your progress, it's showing all of your learnings. It has literally your name, your face, your LinkedIn profile attached to it. It is the ultimate proof that you've done your project. I hope that gives you the answer that you're looking for him, but let me know if you have any questions about that. Okay, cool. That really does wrap up our project now. I think this is the part where we say goodbye. Oh my goodness. It is the wrap already. And I can't wait to continue building out this VPC with you. There are still many other components to a virtual private cloud that we can touch on. Things like a route table is just a start. There's also things like access control lists, like ACLs. There's also something called network peering, which is like, what if you want two VPCs, two private cities to talk to each other in the AWS cloud? Oof, a very, very cool topic too. But we shall wait for the next project. I shall see you then. Let's stay in touch in the community in the meantime. So ask all your questions there. Let's chat there. Let's celebrate each other's wins when we finish our documentation and our projects there too. All right, thank you again, and I'll see you in the next one. Bye. See ya.